everyone, welcome back to my math teaching online today. Um, in this video, I would like to announce to you that we are at the last section of our second calculus course online. I have been creating it and develop it over for 2 months. And this is the last section in our online course, second calculus course. And because it's in the last section, I call it a bonus unit. And why do I call it the bonus unit? Because back in the 20 years ago when I was learning this section, this not in my 12 calculus course, but in the first year of university course. So in this unit, you don't have to write the quiz if you sign up to my course. You don't have to write the unit quiz like the other units. And most of the major of work, I have done it for you. You can have access to my online course with reading on my notes, and I have done it by my handwritten and upload it in details for you to show you step by step, and you just read through it, and that's your homework for this section. Very easy. So I call a bonus unit. You can go to my you can sign up to my course, calculus course, with two ways. One is my mathteaching.ca. I wrote it here. So you can Google my mathteaching.ca. You can have access to my courses to learn free online weekly education. I also post some of the poems and some of the beautiful videos or pictures there as well for you to enjoy during the time of learning. The second way you can purchase my full course. You go to math courses blue rooms -online.teachable.com. I wrote it here. So if you have to take the first year calculus in university, I strongly advise you to take my courses before you take the course in university. First of all, it gives you a smooth transition from high school all the way to university, at least in terms of mathematical concepts. The workload in university is a lot more than high school. I coped with the culture shock when I was learning. It requires you also strengthen your reading skills at a high level. So if you read my last section here you go, it strengthen your reading skills. And I mean, it's important, right? Because time management and your reading skill is two factors affect your success in university. Anyway, I hope you will enjoy your online learning. Education online is not a bad at all. It helped, we give you the tools for you to be self-directed learning and self-motivated. It is so hard if you have to do it on your own, but in our course, we give you a guidance, the direction. You learn which one you learn first, which topic you learn next, and the lesson well connected together logically to put them together in terms of logical mathematics language. So you will understand it a lot better. You will comprehend this topic a lot better. I wish I was born in this generation to have all of this advantage that you have. So why didn't take it when you have it, right? Anyway, I'm going to talk about the lesson today. So in this unit, you will have two type of lesson. The first one is converts coordinates from Cartesian coordinates to polar coordinates. And the next lesson, I will show you how to sketch the polar curves. So let's go back to the unit. So I have on the bar, the question I wrote here is say, find the rectangular or Cartesian coordinates of the point from the polar coordinates. So given you the polar form, we ask you to convert is to the normal form, the regular form. So what is the polar form? The polar form in terms of radius and the angle theta. So that is the polar form. Now, the Cartesian form is just the normal form of x and y coordinate you have learned so far. So how do we convert from our polar form here? Obviously, give you the radius and the angle 5 pi over 4 theta. We ask you to convert to this Cartesian form, right? So let me remind you a little bit. To do this, you have to remember the sentence x equal r cos theta and y equal r sine theta. Now, where did this come from? Let's remind you a little bit. If you have a unit circle, right, this is point P, and this is angle theta. So all the way from here to here, this length is a y, right? And if you go back dotted here, this is your y coordinate. And this length is your x. So if you say sine theta equal opposite over hypotenuse, and this is the r radius of the unit circle, right? So then sine theta equal y over r, right? Opposite over hypotenuse. So click this up, you have r times sine theta equal y. The same like you do for x, right? And that's why where this sentence came from. So I just show you a little bit. Now let's apply this to our coordinate. So now we will say our r here is 3. So x equal 3 times with the cos of our angle is 5 pi over 4. And this is 3 times with sine of 5 pi over 4. So let's figure out what is the cos of 5 pi over 4. So this is pi all the way from here to here. This is divide by half, you have pi over 2. Divide this pi over 2 by half again, right? So this angle here is pi over 4. And pi over 4 is a 45-degree angle, which is the length of sine and opposite and adjacent is the same. But we have 5 pi over 4, so our angle is not in this quadrant, but in which quadrant? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4 in this quadrant, which is, this is the angle, right? So this is minus 1, and this is also minus 1. So substitute this, we have 3 times with the cos 5 pi over 4 is minus 1 over square root 2, right? So minus 1 over square root 2. And the sine also the same. So to convert this, we have minus 3 over square root 2 for the x, right? For this x equal minus 3 over square root 2. And for y, we have the same because the angle 5 pi over 4 have the same coordinate for x and y. So also minus 3 over square root 2. So that is the Cartesian coordinate. So from polar coordinate, we convert it to Cartesian coordinate, and that's what we get. Okay, that's not a bad, right, lesson. Now let me show you the next one, 4 and 5 pi over 3. So we're going to convert this coordinate 4, and the angle we convert is 5 pi over 3. So again, x will be equal to r, which is 4, right, times with cos of 5 pi over 3, and y will be equal to 4 times with sine of 5 pi over 3. Now, what is the angle look like? From here to here is a pi angle, 180 degrees. We'll divide the section by 3. So this is 5 pi over 3. From here to here, this angle, theta, right? If you drag this one, drag this down here, drag this down here. So the part all the way from here to here is a 2 pi over 3, which is right here as well. Down here is 3 pi over 3, make a pi. And down here is 4 pi over 3. And up to here is 5 pi over 3, is this angle. So it's in the 4 quadrant, right? And it means this is 60 degree angle. And if a pi over 3 equivalent to 60 degree angle in this 4 quadrant, then this length opposite with 60 degree is minus square root 3. Everybody learn trick, you know, the expansor triangle, right? So this is just based on the expansor triangle. So this is minus square root 3, and this radius is 2, and this is 1. So the sine of 5 pi, the cos of 5 pi over 3 is 1 over 2, right? 1 over 2. So this equals 4 times 1 over 2. And the radius is always positive, right? And that turned out to be 2. For this one, if we substitute in 4 times with sine of this angle is minus square root 3 over 2. Minus square root 3 over 2. So cancel, cancel. We have minus 2 square root 3. So our Cartesian, this is polar, convert to Cartesian will be x and y. X is 2, and our y is the coordinate, minus 2 square root 3. What's that? So that is the coordinate in Cartesian. If we convert from polar coordinates, which is r and the angle theta, to x and y here. So let me continue this video with the last question, and I will end our video short today. So the last question C here say convert from minus 3, 3 to polar coordinates. So now we go backward, right? Go backward. So we have x and y, right? This is x and y, minus 3 and 3. Now we have to figure out what is our r and what is our angle theta in polar form, right? So now we go backward from Cartesian to polar. So this is Cartesian. And this is polar. Now we go backward. And how do we go backward? How do we do that? Okay, so let me figure out the same trick, right? We will say our x here equal r sine theta, and our y equal r cos theta. But in this question, we also notice tan theta equal y divided by x. And why do I say that? Because, okay, let's do reverse, okay? Let's say if you have the unit circle and you have a point P here, all the way from here to here is your y, all the way from here is your x, and this is your angle theta. So obviously sine theta equal y over, and this is your r, right, radius of circle. So your sine theta will be equal y over r. Your cos theta will be equal x over r, and your tan theta will be equal sine over cos, which is y over x. And your radius, this coordinate actually is x and y, right? X and y. So if you want to find r squared will be equal to x squared plus y squared based on the Pythagorean theorem, right? C squared equal a squared plus b squared. So r squared will be equal to x squared plus y squared. So r will be equal to square root of x squared plus y squared. So this is the hints for you to convert it back into the polar coordinates. So now let's do that, right? So our, let's find out the r first. So our r will be square root of minus 3 square, which is 9. And with 3 square here is also 9. So equal 8 square root of 18. Take out the radical. This is 9 times 2. So it will be 3 square root 2. So that is our r. Now we know our r, right? This is r. Now let's find out the angle. The angle we use tan theta. So we're going to use this expression. Tan theta equal y over x. And our y is 3. Our x, so this is x, this is y, right? Our x is minus 3. So tan theta equal minus 1. Now what angle have a minus 1 as the tan? The only angle have the value of ratio of 1, tan of 1 or minus 1 is the angle pi over 4. But in which quadrant? So let's see in which quadrant. We have the first quadrant is A, positive for all angle. The second for sine, positive for sine, positive for tan in this quadrant. So our angle is not positive but negative, right? So it had to be in this quadrant or so it's going to be in the second quadrant for 10 because there you will have a negative 1, right? So negative 1 and 1, and this is the theta. And in this quadrant as well. So in here you have 1 here and minus 1 here. So tan theta equal negative 1 in the second quadrant and the fourth quadrant. The fourth quadrant. So in the fourth quadrant and the second quadrant, we have a tan theta equal minus 1. Because y divided by x is 1 divided by minus 1, which is minus 1. Minus 1 divided by 1 is minus 1. So our angle theta turned out to be, this is pi over 4, 2 pi over 4. So 1 pi over 4 in here, 2 pi over 4, and 3 pi over 4 in here, right? So 3 pi over 4 is our angle. What else do we have? In this quadrant, It will be 1, 2, 3, 4, 5, 6, 7. It is 7 pi over 4. So 7 pi over 4. That is our theta. So it turned out for 10 equal minus 1, we have two angles. One in the second quadrant, one is the fourth quadrant, which is 3 pi over 4 and 7 pi over 4. Now keep in mind that this question doesn't tell us how many rotations we have. What is the restriction from where to where between the angle, right? So it means we can have many angles with the same values like that if we go around the unit circle. So therefore, the general answer, so I'm going to put in here general answer, right? General answer of our polar coordinate in this case will be what? The R here is, where do we get the R? Here, this number, right? 3 square root 2. So 3 square root 2 is our R, and our angle will be 3 pi over 4 times with 2 pi n. It means so many rotation, it go back to the same position, right? So you will get that. And another answer for this will be, our R and theta. R will be the same, 3 square root 2. And another angle is 7 pi over 4 times with 2 pi times with n interval. And that is our answer for this question. So I hope that my video here today is short video and is very clear for all of you. Now this lesson is not a difficult lesson. So I don't bother to go back and summarize for you. That is the solution we get. So thanks for watching and stay tuned for my next video. My next video will be about the, let me see. So our next lesson will be about the sketching the curve, how we're going to learn the names of on the polar curves and how we sketch it. There are two ways of sketching them. One is in a formal way, so we know the accurate values, how to convert from the angle, from the curve of sine and cos we have learned before in trigonometric. And another one is using the shortcut. So I will show you both. Of course, everyone loves the shortcut, right? Anyway, so that will be the last section, the last lesson in our course. And I will make the quiz and exam and check out the solution before I publish it to all of you. So stay tuned and watch out for the second calculus course will be published. And again, knowledge has no border of limited learning. And if you think that online education is so accessible, so affordable, so cheap, so easy, you can rewind, you can retape, you can relearn anytime as your long life lesson, then go to my website and purchase math courses online.teachable.com. You will have access to all my handwritten notes on the step in this section to show you how to draw the polar curves and relearn for the previous lesson before. Just remember to me, your academic skill, right, is the rehearsal of learning. Because if you don't use it, whether you use it or you lose it. For motor skill, like riding a bicycle, swimming, 20 years you not go to swimming. When you jump back to swimming pool, you still be able to swim, no problem. That's we call a motor skill. But for academic skill is different, right? If you don't use it in 1 year or you don't use it in 2 years, the mathematical language is gone. The computer science language is gone. And therefore, you got to on the time to keep update with it. And that is the nature of academic skills. It sounds like scary, but that is the reality, right? Um, so I just remind you, and that's why if you go online, education is so much benefit now for you to learn the private lesson like this to me, face by face like that. So like a private tutoring, but a lot cheaper, affordable, accessible. You can rewind the tape, you can relearn in your own pace, and no social distraction to help you to focus. Self-motivation, self-directed learning. Thank you for watching and good luck for your online learning. I hope you enjoy online education as soon as possible and get on to drop a line, get onto my course and go for a ride. Anyway, thanks for watching. Bye for now.